Hi everyone, my name is Daniel here at the Data Services team in GameAnalytics, and today I want to introduce you to Player Warehouse. Player Warehouse gives you data on a player and event level. You can use it to identify player behavior, understand how they progress through your levels, and even understand the intricacies of your game economy. The goal with these videos is to be able to give you an understanding of what is Player Warehouse, how the tables are structured and their schemas, and then run through a few use cases like the busiest time of the day for your game, retention, or how your players progress through their levels, where do they get stuck. Now we want to understand how the data goes from your users all the way back to you. With the SDK installed, your users will start sending events over to GameAnalytics. We then collect that data, clean it, and transform it. For Player Warehouse, we aggregate it on a daily basis, on player level or event level. We then move them onto a BigQuery project. GA will create this project and share it with you, so you have full control over who has access to the data. Okay, so now let's have a look at the tables that you get access to with Player Warehouse. All of these tables are updated daily on what we call a checkpoint, and they are then partitioned by day, so by checkpoint. The first and the main one is the player table. It's aggregated on a player ID level, and it's where you can get all the information about your player, their country, their device, if they're a paying user, or when they install the game. You also get access to some statistical information, like session count, session length for that day, and others. Then there's the business table. This is mainly payment events, and it's aggregated on a transaction level. And here it's where you'll find information about in-app purchases or other business transactions. The progression table, it's filtered on progression events, and it's aggregated by event ID. This is where you can get the information about your levels, and it's very simple to calculate completion rate or fail rate. The resource table, it's aggregated by event ID, and it's mainly designed to include information about in-game transactions. And here I'm talking about purchasing an item with virtual currency or losing a life, depending on how you structure this in your game. Lastly, we have the session table. This is aggregated by session ID. You get an entry per session, and you can get the session length or when it started. This is very useful, and we'll use this in one of our use cases to understand what is the busiest time of the day for your game. Okay, so now let's try to identify when is the most popular hour for our game. What we're going to do is use the session checkpoint table, where we get access to the session start timestamp. We're going to extract the hour out of that. We're going to just count the amount of rows. This is because the table has an entry per session ID. And then we can just calculate the average of the session length of those sessions. We're having just a look at the snapshot of 2 days ago for a specific game. When we run this, we're going to get here our results, and I've ordered this by the session count. Obviously, I did this the other way around, so we're getting the least popular hour is at 2 in the morning. But if we scroll to the bottom, we can see that the most popular hour is 11 p.m., 9 p.m., then we have here 2 p.m. coming close, but we can also see that it seems that the length of the sessions is highest as well here at 11 p.m. Okay, so on this use case, let's have a look at progression. So on this use case, let's see how players go through our levels and where do they fail the most. For this, we're going to use the progression checkpoint table. And here we have dates on the form of checkpoint, game IDs, player IDs, a few information about score as well, progression status, and then progression 1, 2, and 3. These can be defined as world, level, depends on how you implement this on your side. I've written here a small SQL query where we're identifying progression 3 because that's where we're tracking the level on this demo game, and then just doing a count distinct player ID for start, complete, and fail. So essentially here we're trying to understand where are players failing the most in comparison to the start, right? So running this, we can see that it doesn't take too long. And sorry for moving here the camera, but we can see that it was about to take 63 gigabytes. That's the expected cost, but we can see that it took 166 megabytes. This has to do with the way that we cluster and partition our data. So looking at the data, that's what we're here for. We can see, for example, 659 started the jewelry store level, and 247 of them actually failed. Now, you'll see that these two numbers won't add up because we're looking at distinct players. The thing is, here we're trying to identify how many players actually failed the game before they even managed to complete. So this is a bit hard to identify, right? We're looking at this, but is it 50%? Is it 40%? Does this compare to this? So let's transform this into percentage just to get it out of the way here. So let's do simply, we'll bring progression 3 so we know what we're talking about. And then grab the complete and divide it by the start. And let's call this the complete percentage. We can do the same for the fail. So fail percentage. I'm here focusing on the fail percentage. I want to know how many of the players actually fail this game, regardless of them being able to complete it or not. So we run this. We're going to get here that we have 37% fail percentage for the jewelry store, 35% for the museum, but clear outliner here on jetliner, 49%. So almost 50% of the players that have attempted this have failed at least once, and only 63% of them actually managed to get through this level. So we're clearly seeing here that this might be a bit too much of a complicated level. We might want to do some adjustments. Now we're going to have a look at the retention use case. So for that, we're going to use the player checkpoint table, where we have access to the player ID and when they install the game. The checkpoint that you see over here is the date of the entry of that row. So we're going to use that to make sure that we're picking only the new players. So first, we get the new players or new users as I've defined here. We identify the checkpoint as 3 days ago, and we're making sure that the install timestamp is the same as the checkpoint. So they're installing the game on the same day that we're looking at. And here I'm just filtering for our demo game. After that, we need to identify out of these players, how many actually came back. So what we're going to do here is grab the checkpoint of 2 days ago instead of 3, and make sure that the install timestamp is equal to that checkpoint minus 1. And still filtering here for the game ID. Running this, we're going to get here some results. Just waiting for it to load. And we get here actually 276 users installed the game 3 days ago. Out of that, 98 came back, so giving us a 35% retention rate on the first day. But okay, what if we want to specify on our paying users, we want to understand what is the behavior for those? The player checkpoint table also has value, it's a boolean, and is just called isPaying, and identifies if the player is a paying player or not. So adding this to both of the queries, and we run this again, just letting it do its thing, and we get here, okay. So from the players, those 276 we had before, 7 of them are actually paying customers, and 6 of them returned, so giving us an 85% return. What we can also take out of this is, out of those 276 players, 7 of them were actually paying on the first day. So there's 2 insights we can take out of this, which is a very simple and straightforward query.